Check, check.
Oh, okay, yeah, I'm seeing audio.
Check, 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 check. Check, 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 check. You can hear me? Okay, cool. Good levels too? Awesome.
Thanks.
Okay, good morning. Welcome to OARC 27. It's great to see so many people in the room. I will first of all hand you over to Dwayne Wessels as OARC Chair, who has a few remarks to make.
Thank you, Keith. And yes, welcome everybody. This is, of course, the 27th DNS OARC meeting or workshop. Some of you may remember or may know that this is not the first time we've met in San Jose. Actually, our third meeting was here in San Jose, hosted by Cisco, I believe. I was there, and I know a few others were there, but I'm interested to see a show of hands if other people remember being at that meeting. I can't see that. Yeah, we should. So I thought I'd, just for fun, go through some of the things that we were talking about back then and who some of the people were. There was a presentation on internetwork abuse. Back then, that was sort of one of the things that DNS OARC was trying to focus on was handling abuse and reporting and whatnot. There was a talk on building CDNs. There was a talk on what's new in Bind 9.4. And also there was a new release of NSD version 3. DNS monitoring tools was a topic. Finding open resolvers was a topic. That was mine. Placement of TLD name servers, still an interesting topic today. Also, recent reflector attacks was a presentation. What's going on with DLV? And there was also, the first presentation of the meeting was actually a project called, I think it was pronounced Codons, C-O-D-O-N-S, which was like a distributed hash table DNS thing. So I know I was there, Matt Larson was there, Sebastian Castro was there. Sebastian gave 3 of those presentations at that meeting, so good job, Sebastian. And Peter Loscher was there, he gave 2 of those presentations. So that was 11 years ago, and here we are back again today. Thank you, everyone, for being here. It's great to see, how much we've grown and matured, and in some cases moved on, and in some cases not moved on to new topics. So with that, I'm going to turn it over to Keith for some more opening remarks, and I'll be back to talk to you in a minute.
Okay, thanks, Dwayne. Yeah, my stuff is all kind of tedious administrative stuff, but for those of you who don't know me, I'm Keith Mitchell, OARC President. Yes, I was at that meeting. In fact, I think that was my first day working for OARC, so that was interesting. Anyway, we have 175 registrations, so I think that makes this the biggest OARC meeting ever. It's good to be in the heart of Silicon Valley, where much of the DNS originated. A few administrative things before we actually get on with the real meat of the meeting. We're using the NANOG network, so use the NANOG RN SSID if you can. There's some credentials you need for that, just NANOG. There's also a completely open Hinky network if you can't get that to work. That's the link to NANOG 71. So we've done meetings in partnership with NANOG a number of times, and it works generally very well. So again, thanks to all the NANOG staff for their help. One of the things that we did last year when we co-located in Dallas that we'll be doing again this year is that it's my job to digest all the proceedings and turn them into a presentation to the NANOG plenary for the wider operations community about what all kinds of strange things are going on in our little obscure DNS corner for them. So I'll be doing that on Tuesday. Few administrative things. If you have any concerns about food allergies or dietary requirements, please speak to Dinesh, who's at the back of the room there, and he takes these things into account and will be able to advise you on the food that's available. Fire alarm procedure, there is no drill planned for today, so if the fire alarm goes off, then it's a real thing. So either exit via there and go downstairs, or exit via the back and go out the front entrance of the hotel, and the assembly point is in the park outside. Jerry Lindstrom, our software developer, Jerry is sitting at the back of the room, and he wants to show you some of the work that he's been doing with new tools during the breaks. if you want help, or you like to see some of the cool new stuff he's been doing with Drool and Check My DNS and a number of other tools, then he's your guy to speak to. We'd quite like to do a PGP signing session tomorrow, but we need a volunteer coordinator for that. So if you'd like to help out, then please do step forward. Badges, anyone with the yellow lanyard is a member of the OARC staff or board or PC. If you need help with anything, then bug somebody with a yellow lanyard. Welcome to all our first-timers. It's great that you're here. Thank you. I hope you find it worthwhile. And I'd just like to ask all our usual suspects to please take a little time to speak to the first-timers and make them welcome. When you leave, you can keep the badges, but we'd appreciate if we get the lanyards back so that we can reuse them for next time. We have a social event this evening, which is in a nearby bar. Spaces are limited, so please pick up a ticket if you want to go from the registration desk during the breaks today. When you get your ticket, take it to the venue, and you'll be able to exchange it for 2 drinks coupons, and there's a little bit of food laid on. Once you've spent the coupons, then there's a cash bar as well. If you'd like to submit a lightning talk, then please send that to submissions@dnsoarc.net by the end of this afternoon's break, and the PC will review these overnight, and then there was a lightning talk session at the end of the workshop proceedings tomorrow. Another thing that's been added is, as many of you are aware, ICANN decided to postpone the rolling of the root key signing key, which was due to happen next week. So there's a special session at 6 o'clock in this room. If you're interested, you can hang around for that, and there will be half-an-hour discussion available with the ICANN staff who are here. And of course, that's the very topic that Dwayne's first up of when I stop going on about admin stuff. We're webcasting on YouTube, so there's also a Jabber room for remote and in-room participation. Please try to not make any undue noises in the background with your devices or selves. If you have questions to ask, there's a microphone in the middle here. Please line up there and identify yourself and affiliation before asking a question. And we're on the usual social media channels via #OARC27. I think we got almost all our speaker uploads. We got them all for today. Thank you. If you've still got to upload your slides, please talk to me or Dave or William, and if you have any special AV requirements. We have a timekeeper at the front here. Please be aware that the timekeeping is to the end of your speaking, your time speaking, not to the end of the 30-minute slot that you're speaking, and there's still some time for Q&A after that. And if you're up here, please do not bring any RF emitting devices that would insert interference into the audio stream. And thank you to all our speakers. All of our speakers are here on their own time and expense. We would not have a workshop without the work that they do to have interesting stuff to present and to present it, so thank you. I mentioned Jerry's demos at the back there. Please go talk to Jerry. He'll be very pleased to show you what he's doing. And that is it, basically. I will now hand over to Pete Barber, from VeriSign, who is our program committee chair, who is session chair for the first chair this morning. Look forward to a great workshop. Thank you.
Good morning. My name is Pete Barber. I work at VeriSign. And this morning's sessions will be mostly about DNSSEC. So to kick it off, we'll start with the presentation that I know everyone is waiting to hear about. And this is Dwayne Wessel's look at RFC 8145, trust anchor signaling for the 2017 KSK rollover. Thanks, Dwayne.
All right, thank you. I am not in control of the laptop, which is fine. So yeah, I'm looking forward to this. It's been an interesting week, as you can probably imagine, and I expect some interesting discussion, questions after this. So close. All right. We're good to go? Okay. Yeah, so this is about key tag signaling data for the rollover. It's described in an RFC called RFC 8145, which I hope from now on everyone will be able to remember. Some background, if in case you need a little background. The KSK was scheduled to be rolled on October 11th. That's now changed. What that means on that date is that the root zone is published with DNS key RSS signatures from the new key from KSK 2017. And any validating name servers require updating of their trust anchor set before that time, or they sort of stop working. And it would be really nice to know if all these validating name servers had actually done that and updated their trust anchors. So in case you're wondering what a trust anchor is, you can, I'm not going to read this, but you can turn to RFC 4033, where there's a very nice definition of what is a trust anchor. You probably know this already, but you might wonder how are trust anchors updated, and there's generally three ways. There's RFC 5011, which is automated updates of DNS security trust anchors. You might have an updated trust anchor via some sort of operating system update. If it says updates are ready for your computer, or maybe you installed a newer version of Unbound or Bind, the new trust anchor might sort of come in that way. Thirdly, if you're the type of person that maybe likes to manually update your config files, then you may be in a position to manually update those files in the trust anchor. So how could we tell if a trust anchor got updated? You might think, well, maybe there's some kind of query we could do. We could query all the name servers on the internet and ask them. That's sort of impractical for a number of reasons. I would like to note, however, that Unbound does have a query that you can issue if you have access to it and are allowed to query it. There's a query that you can make as of a certain version, version 1.6.2, and it will tell you what its trust anchor set is. So that's very nice. That unfortunately doesn't work, at the internet scale. There have been proposals to have some kind of sentinel record in the root zone that's only signed by the new key, and then you could query for that, and if it validated, then you would know that it has the new trust anchor. But unfortunately, that doesn't really work because of the way DNSSEC is designed. If the new key is in the zone and it's signed by the old key, then the new key is sort of automatically trusted, and this doesn't work. So another option is that maybe you could have validators self-report their trust anchor set, and that's sort of what this is all about. So there's an RFC 8145, that describes how to do this. It uses this phrase called key tag signaling. The idea is that the validators periodically report their trust anchor key tags. If you don't know what a key tag is, this is used throughout DNSSEC in various ways. It's a 16-bit number that identifies keys as signatures. It's very similar to a one's complement checksum over this key data. For the things that we're interested in today, there are two key tag values of interest. One is 19036, that's for the old key, the 2010 key, and 20326 is for the new key. So per this protocol, these key tags are reported to the authoritative name servers for the zone. So in this case, the root zone and the root zone name servers. And the RFC says that these should be transmitted about as frequently as DNS key records expire from cache and whatnot, right? So on the order of, 2 days, 1 day TTL, something like that. The RFC describes two forms of key tag signaling. One is in an eDNS key tag option. So this is a new option code that was allocated for this RFC. And the idea is that when there's a query going out for a DNS key, the validator would append this to the eDNS section and saying, these are my key tags that I have. The other form is a separate individual query where the key tag data is embedded in the query name using a hexadecimal representation. So for some of this, it will be useful to know that the old key is 4 Alpha 5 Charlie in hexadecimal, and the new key is 4 Foxtrot 66. So this chart shows kind of the timeline of how things progressed. This internet draft first appeared in December 2015. In July of 2016, it was first implemented in Bind. And in February, this was adopted by the working group, by the DNS OARC working group. I'm sorry, that's not right. Well, finished in February. Yes, thank you. Finished in February. And in April, it made it through all the last hurdles of the IETF process and was published as RFC 8145. Shortly after that, it was first implemented in Unbound. And in May of this year is when I first thought that it might be a good idea to start collecting some data. In Bind, this is, you can see here the configuration option they would use is called Trust Anchor Telemetry, and in Bind it defaults to yes. In Unbound it's called Trust Anchor Signaling, and it defaults to no. So there's these two forms of signaling, and one of the things I was curious to find out in all this is which ones got implemented. Both Bind and Unbound implemented the QNAME-based signaling, and I was curious if there was ever any evidence of the option code signaling. So I took a week's worth of PCAP files from our root servers and scanned through all of them, and I found exactly 2 packets with an EDNS option, EDNS key tag option, but they didn't look right. What they really looked like was EDNS cookie options, because the option length was 8. And this is explained because there was a bit flip during transmission of these, and option code 10 got changed into 14. So it looks definitely like, from people who've chosen to implement this, QNAME is the easy way, and this wins the approach. Okay, so let's get into some cool data here. As I said, these signals are sent to the root name servers. The data that I have to present today comes only from ARoot and JRoot, which VeriSign operates. And I want to be very upfront that there's a bit of a selection bias here, because only new implementations or new versions of implementations are providing this data. So you have to be running a pretty recent version of Bind or Unbound to be sending this data. Here's an example of what the raw data looks like that I have access to. It's stored in some Hive Hadoop data, and this is an example query that I can use to pull it out. And so you can see here, here's a timestamp column. Here's the actual key tag values. This was done very early on in the process, so it's mostly the old key. There's a couple with both keys here. These are the source addresses, masked out, whoops, and the destination addresses of our servers, and then the year, month, and the day. So I take that data, and for each day I pull out the key tag queries, and I filter out any key tag queries that are not for the root zone. So I obviously only want the root zone queries. And then I count the number of source IPs whose tags contain only the old key, only the new key and the old key, and also the new key or the old key. And the reason for that or is because some of these signals have more key tags than just the 2 that we're talking about today. Some folks have configured other trust anchors apparently for the root, and so those will show up also. And I'll talk a little bit about that later. So this chart shows the number of sources providing the data over time. And when I started in May, it's down in the 500 to 600 range, and more recently, it's in the 1400 range. This is number of IP addresses per day. So all of my data is sort of bucketed by day, and that's an important thing to keep in mind. If you looked at this, if you aggregated it at periods longer than a day, you would see more, and that's really because a lot of these things have dynamically changing IP addresses, right? And so they may sort of get double counted. And you can see also these vertical lines representing the time of that the key was published and the time when the RFC 5011 hold down timer ended. And you can also see way over on the edge the, the beginnings of the time for the rollover. And so you can see this data is a little bit noisy. You know, it varies from day to day. It's a little bit jumpy. That's what the points are. The lines kind of smooth it out. But also keep in mind that this is only from A root and J root. Yeah. Okay, so this is probably one of the most interesting graphs here in the talk, and this is what I was looking at, you know, day by day as the rollover was happening, and you know, you can sort of imagine back in June and July, you know, I'm watching these lines very carefully and getting excited as they sort of change a little bit. Again, this day here, July 11th, is when the key was published in the root zone, and 30 days later, we have a lot of excitement where these two lines cross, and that's evidence that a lot of these things, you know, successfully did the RFC 5011 rollover. But even before the key was published, and even before the hold-on timer ended, you can see down here this green line representing key tags for both keys, for the trust anchor for both keys. You can see it's already, you know, going up. And that's because people either updated manually or a software update. I know that if you pulled out a new version of Bind, it automatically, you know, gave you the new trust anchor in its config at that time. So there was this evidence early on that the new key was being deployed and adopted, you know, well before it was actually published in the root zone. Now the concerning part is after that, after these lines crossed, you know, I was expecting really that they would sort of continue on their trajectory of diverging. This red line, you know, should have gone down closer to 0, and the green line should have gone up closer to 100, but it's pretty flat. Before I go on to the next graph, I'll also point out there were down here these two blue points in September. These were two key tag signals of someone reporting only the new KSK. So they had apparently did not have the old KSK, and if that was, you know, true, then it means they didn't validate anything because the key was not being used to sign at that time. So that happened twice. A little bit curious. And I'm glad it only happened twice. You know, it didn't persist. Okay, so I should have said this graph represents the percent. This is a percentage on the y-axis. This is the percent of signalers, and this graph is the count of signalers. It's the same data, just kind of looking at it a different way. Here again, the red is the folks that are doing only the old trust anchor. Again, this is per day. So in a given day, these sources reported only having the 2010 key. The green for that day is sources reporting both the 2010 key and the 2017 key. And you can see maybe there's a little bit of yellow in between there. And these are sources that sort of send mixed signals, if you will. Sometimes during that day, they sent only the old key, and sometimes they sent a signal with both the old and the new key. But these, you know, I was worried for a while that there might be more of these. This is almost negligible, the amount and number of yellow. It's not very many. All right. Another thing I was interested in is how often do we see unexpected or non-IANA key tags in the data. So I observed 19 key tags for root other than the two that we've already talked about, but these came from less than 10 IP addresses per day. And that's what this graph shows. The green at the top is the expected signals, the two IANA keys, and the blue and the red represent either key tags of only, the red represents only non-IANA key tags, and the blue represents both IANA and non-IANA key tags together. So I think it's nice to see that that line is nice and flat down at the bottom. So another question I had is, how often do we see the key tag queries? You know, are validators reporting them more than once per TTL? And so I intentionally, you know, at home and in my office I ran bind in one place and unbound in the other place, and did some packet captures and examined the data that way. Well, I have two graphs to show. So that's what this one is. This one shows the red represents the key tags emitted by bind. Very regularly, every 24 hours, it sends a new key tag signal. The blue data represents key tag signals coming from unbound, and it's not quite as regular, and it's every 12 hours, sometimes less than 12 hours. So I thought that was interesting. What this graph shows is this is the median time between signals from the same source IP. So take all the data, you know, group it by source IP, calculate the median time between its signals, and plot this as a histogram. And it's got these very, very strong spikes. You might notice down at the x-axis, there's a little bit of histogram data there, you know, not at the daily boundaries, but the fact that there's these strong spikes at every day at 24-hour intervals, that tells me that almost all this data is coming from bind, which again makes sense because that's where it's enabled by default. And in unbound, where it's not enabled by default, I don't think we're actually seeing much data at this time. If we were, there would sort of be more fuzziness here, and we would see some spikes or whatnot at 12-hour-ish intervals. And again, this is only from A root and J root, 2 of the 13 root server letters. So, you know, for example, the way you can interpret this is from A root and J root. Most commonly, we see signals from the same IP about every 2 days, which is good. If we had more letters, then this graph would look a lot different. It would be a different distribution, and we would see the same sources more often than that even. Okay, so I believe this is my last slide. So wrapping up, these key tag signals, in one sense, I would say they're of pretty good quality, meaning that you know, the data is emitted regularly and predictably from bind. I didn't see any evidence of anyone trying to, like, you know, spoof the data or make up their own key tags. I don't think that's going on. As I said before, there's probably a selection bias here because this only comes from very recent versions of those products. I predict that the eDNS key tag option in the opt record will probably never get deployed. I would very much like to thank ISC for deploying this a long time ago and making it the default. I very much appreciate that. For LNet Labs, I would really encourage you to also turn this on by default if you could. I think that would be helpful. And any other vendors or anyone else that has to deal with trust anchors and key tags, I would also ask you to implement this RFC so that you know, going forward we have even more data. That's the end, and I think we have, how much time do we have for questions? 5, 10 minutes, something like that? Oh, 15 minutes, oh, good grief. I might tire before then. Michael, go ahead. I don't think your mic is on.
There we go. Mike Sinatra, YesNet. Thanks, Dwayne, for both coming up with the idea for this protocol and also this presentation. Whoa. Just a data point, not a very good one, but on Wednesday, I got a nice email from ISC saying, hey, we've identified 3 servers that are sending the wrong key tag in the YesNet domain. Exactly 0 of which are actually validating resolvers. And they are all, it turns out, authoritative servers, and one's completely a testing server with interesting configuration, which is that DNSSEC validation is turned on, but recursion is turned off. And that particular combination does cause bind to still send the telemetry data.
Okay.
But I don't know what the actual effect is. So I've now configured one of them to have a completely wrong trust anchor, so now it's going to be one of your unexpected key tags is going to be sent. And it seems to be doing fine. So I don't know what, and I'm working with ISC to kind of figure out what the operational consequence of this interesting configuration is. It only affects a couple of servers, but it's just kind of interesting to me. But the question I have actually is how confident are we with this data? We had kind of 100% sort of falsish positive rate in ESNet. I'm just wondering what kind of confidence you think you have in the data that you've got right now.
Yeah, I think we're just sort of beginning to scratch that surface, to be honest. As you know, developments have been happening really quickly throughout this week, and it's good that you've had some outreach. So at this point, I can't really say one way or the other, but I think that we will learn a lot more in the coming weeks, months. Yeah.
Hey, Dwayne, George from APNIC. Can you go back to 19? No, 19. So.
This one?
Yeah.
Okay.
So, I feel you're right when you say it's a biased sample. I mean, it is. And the understanding is it's the sample of only things which are new enough to be either under conscious update or automatic update of software. And you've got two classes of thing. You've got a thing where you have to turn on the feature, but you saw that. You definitely saw that because of the two time bars. So you know some people are turning this stuff on in Unbound. And the other population are running bind.
Let me make sure I understand your question.
I haven't got there yet.
Okay. I'm not sure that I'm seeing data from Unbound. I turned it on for myself intentionally.
So you believe the sample who showed that they were doing a refresh on approximately 12 hours are not the Unbound people? I thought you said that it was bind on 24 and Unbound on 12.
So let me clarify. The red data comes from my named running at my office.
Oh, this isn't a sample across the population.
The blue data comes from my Unbound running at my house.
Skip that part. Back to 19.
Okay.
So the thing I wanted to say about 19 is there are two very distinct behaviors on this graph. There is a red behavior that at the point of the transition day dropped to a flatline state, but before that it was in growth phase. And there's a green population which after the transition date continues to be in growth phase.
Right. Yeah, it's interesting.
So that bottom line of red in persisting state, to the extent there's a growth in the green, if you don't know the difference between red and green, but you can see it segmenting into a stable population and a growing population, that feels to me like a real statement even in a biased sample. You have a distinct behavior in these two populations. Yeah. In all likelihood, the population that red is sampling against is simply the residuum that is not going to update without the operators being hit with a stick. Right. It's not indicative necessarily of a global population. I mean, the underlying question, how much this is reflective of a global population, it's unknown. But this quality, that this is a flatline measure, I find that very interesting.
Yeah, me too. Yeah.
That was me.
Thanks.
Ralph Dolmans, NL Labs. Quick remark, I just changed the default in Unbound, so that will be enabled next to us.
Thank you, Ralph.
Hi, Evan Hunt, ISC. I have some bind-specific comments. Number one, the one person who was sending KSK 2017, that may have been me, because I remember testing that scenario a few times. So there are a few possible explanations for why some bind servers are not rolling to the new key, and one of them, of course, is that they were configured a long time ago with a static trust anchor, and the operator is unaware of the fact that they need to do anything about it. And the other possibility is that there is a bug that prevented the rolling from occurring, and figuring out what the ratio of those two things is going to be important. When we received this data, we started looking with a high degree of focus to find out if there were such bugs, and we did in fact find one. In fact, we found a couple affecting both the quality of the data that you receive and the quality of rolling. Rather, in the case of the rolling bug, it's more of an anti-bug. If you shoot yourself in the foot in a certain way, bind will prevent you from bleeding. until they withdraw KSK 2010, at which point you will bleed out. The problem is if your working directory into which we're attempting to save state is not writable, named will carry on happily not saving state. And in that situation, rather than breaking at that point, which we should have done and which we will almost certainly do in upcoming releases, the server carries on with your initializing key, which is to say KSK 2010, as a trust anchor, and everything validates until it doesn't.
Right.
I don't know yet whether that's going to be a significant part of that 5%. And another factor is that it turns out we're sending trust anchor telemetry information too often. If DNSSEC validation is disabled, or if recursion is disabled, as Michael mentioned, but you happen to have a trust anchor configured anyway, we're still going to send that information along, and it's just noise.
Okay.
I think that covers everything I had to say, but we're going to be addressing these issues and getting better data in future times. The urgency right now is going to be to find out whether actually completing the key role now is going to cause a massive amount of chaos or a small, moderate amount of chaos.
Right.
Thanks.
Okay, thank you.
Alfredo Nominum. So I have a question on the 5%, pretty much. You said you had different IP addresses every day. Did you also have a static environment? I mean, were there some that were not changing?
Oh, yeah, absolutely.
Can you quantify that?
Can I quantify it? So, yeah, it's about, so again, this metric depends on how long you look. So I think if I look at like a month's of data, it's on the order of a few hundred, 300, something like that.
Mm. And another thing, have you done with these 5% a ratio of how many total queries you get? And I mean, the question I'm having is, are these just kind of people behind their dial-up modem that have a Linux running at home, or are these real resolvers operated by sort of for thousands of other people? And have you done anything to quantify that? Well, you can. You can. So, yeah.
So, I haven't looked, other than looking at if they're sort of static or dynamic. I haven't done anything other to say if they're home or corporate or whatever. But one of the ways that this works, I'm not sure if you're asking about the forwarding case, but it's possible that you have a name server forwarding to another name server and then like to the root servers. And we see evidence of that actually. One of the addresses in this set is DNS OARC's open recursive name server. And so I saw all kinds of signals from them. But when that happens, of course, caching comes into effect, right? So if you have like, say, multiple things forwarding to one cache, then they can get negative cache hits and whatnot, and we don't get every signal from them because the cache sort of blocks them.
But you haven't looked into the total amount of volume you're getting from these, I mean, to figure out or digest how many users would be affected?
So I've done a little bit of that, yeah. We've taken some of the data and correlated it to query traffic that we see for ComNet name servers, and looked at which ones send a lot of queries and which ones don't. Yeah, we have done some of that, and I've shared that data with ICANN.
But it's not in there.
But it's not in this presentation. That's right, yeah.
So Warren Kamari, I originally came up with one comment, and I've got three.
By the way, we're going to close the mic line.
Sure. So kind of speaking to Ralph's point, I kind of cherry-picked some of the IP addresses and just did sort of host on the IP address or looked at reverse DNS. And the majority of them seem to be something that had DNS in their name, like ns3.largeisp or something like that. And that was just cherry-picking some and having a look. And it seemed to be more than half, like a lot more than half, didn't obviously look like dynamic IPs.
Okay.
But might have been, the set that I chose or whatever. But of course, those could be forwarded, and so we don't really know.
Right.
As you mentioned, caching makes this fun. Something else that makes it even more fun is we did this, which I think was a really cool thing. And then we also did negative NSEC, which I think was a really cool thing. Mm-hmm. Negative NSEC hides a huge, or potentially hides a huge chunk of this, because if anybody does a lookup for anything which is covered by the NSEC range, they won't actually send this query. Yeah. Which turns out to be two really cool things that put together.
And we kind of knew that in the RFC. it says that, if you want to solve that problem, you should put a record in the zone, and maybe that's something we should consider, is putting these records in the zone with proper TTLs, and then we can be in more control of how often we get the data.
Yeah, we actually had a long discussion in DNS OP on, can we ask for this? And I thought at the time we decided ICANN would probably say no, go away.
Right.
Potentially now that answer may have changed.
Right.
So, I mean, the 5% number, there's no real way to know, but I think that sort of aligns with the sorts of numbers I personally was thinking we'd get from the trusted keys stuff, because we've done a huge amount of outreach telling people, please do trusted keys, and people did trusted keys. Oh, go faster. The 2 yellow things I think might also be a really interesting one. I suspect that those are people running something like Docker, where they write their config to disk, and then when they restart the instance, they have the persistent disk doesn't follow.
It could be NATs, it could be forwarders, it could be lots of things, yeah.
Ed Lewis and ICANN. One thing I want to capture too is I'm surprised how rapidly we got useful data on this. I'm not looking at the data itself, but we have this idea that everything is slow to come out of anything in technology. RFCs take forever. This is amazing how fast this got adopted by the operators. I want to point that out. I think that's a positive, this data even existing.
Yeah, thank you, Ed, I agree.
Brian Dixon. So it's sort of an observation, theory, and question. I suspect that it is because of statically configured trust anchors without the managed key in bind, which may have been persisting across software updates. What I'm wondering is maybe Evan or somebody from ISC can comment, if that was forced to change to a managed key instead of a static trust anchor, are there any downsides to doing that? And if that does happen and then gets released as a security update, maybe that red can go away.
That's under consideration. We've been talking about that. I'm personally uncomfortable with a server that thinks it knows better than you do what you meant in your configuration file. But one possibility that's been suggested would be to deprecate trust anchors in favor of a different command that does the same thing, so that everyone who has a trust anchor configuration is going to have to think about whether that's still what they want.
Yeah, great.
And a second comment would be, I guess I'm not sure about the comment, but does it make sense to do some additional logic on what's in the DNS key set of the root and only send signal for things that are published as DNS key, even if they're not signing, so that it avoids the false signal or leaking information about other configured trust anchors?
Yeah, that's a big question. I don't know. We'll have to take that up for later. And by the way, that's the kind of question maybe that we can talk about at the 6 p.m. session tonight. Yeah.
Alex Dupuy from Google. This is a little lot for me, but so I had one quick question. One of the issues with the forwarding from a recursive resolver such as ourselves is that if we add our signal in there, it's kind of just muddying the waters. If we were to implement it, we might even just do the EDNS option so that it's a separate signal, but I was curious if you had a thought about whether that's more problematic.
One thing I will say is in the RFC, it says if you're using the EDNS option and if you receive a query with a signal and you have your own signal, then you send them separately. You send them sort of two option codes, right? So we would be able to see that case if you implemented the EDNS option per the RFC. We would be able to tell, your tag versus the end user's tag.
Yeah, I mean, I guess it's just if everybody is doing the other thing, then there's a clearer separation.
Yeah.
I don't know.
Yeah, we can talk more, I guess. Yeah, thanks.
Thank you.
All right, thank you.
All right, thank you, Dwayne. Our next speaker will be Scott Rose from NIST. I haven't seen him yet this morning. Where is he? There you are. Great. And the presentation is DNSSEC operations and .gov.
Hello, everybody. I'm Scott Rose from NIST. Basically, we have some data from the operations of .gov, the DNSSEC side of operations of .gov for the last several years. We've been kind of compiling them. We have a little monitor that runs these things every week just to measure deployment originally. And now we kind of delving a little deeper to see how well we're kind of deploying it. Things we've been looking at, we're looking at the algorithms that were used because we kind of care about those things in the US government. Also cared about the DS hashes they're used. And we started looking at NSEC versus NSEC 3, as well as like kind of what the parameters of NSEC 3 are being used. The question of why we're doing this is we just want to see like, what's the health of DNSSEC operations in .gov? Are we doing the right thing? And if not, do they need to be improved? How will we improve them? Or is this something that's perfectly fine? We should just let it go. For most people that don't know, outside of Gov, Gov isn't a monolithic thing. It's more of like EDU. Every agency can do its own thing, and so you get a wide variance of operations. But overall, we're doing fairly well. Within the federal side, because it is mandated in the US federal government, we're about 84%, and that's kind of holding steady for the last few years. And the whole of Gov, that includes state, local, and what we call native sovereign nations. It's more like it's 20% overall because there's a lot more of city governments, a lot more state governments, and they're not doing DNSSEC at all, or some of them are. The algorithms that we're using, looking at the last few years, you can see the majority of still using RSA SHA-1 or RSA SHA-256. That's kind of like the favorite, mainly because these are old deployments and algorithm rollovers are really hard. So a lot of people aren't doing them. As you can see, there are a few that are using at least one that's using ECDSA. This is actually a few months old. We just looked at the stats for the last week of the test we run, and that number 1 is actually now bumped up to 8. Part of that is the issue of there was a time when the actual registrar web interface wouldn't allow you to upload DS record sets from keys that were generated using ECDSA. That's changed. Now we're actually seeing a slow growth of people actually rolling to that algorithm, which is kind of a nice thing to see. Technically, RSA SHA-1 is not approved for use much. We should all be using RSA SHA-256 in the federal side of the government at least. State and local, of course, can do whatever they want. We actually should all be migrating to ECDSA. There's another mandate, but that's not really being fully enforced. So that's why you're not seeing a lot of rolling over to that. We also did kind of a comparison of what people that are rolling over algorithms, what are they rolling from to in the last 2 years. You can see most of the movement seems to be from RSA SHA-1 to RSA SHA-256. I'm thinking that is because they know that the root and gov are signed using that, so they think, okay, that's great, I'm just going to be using that. One interesting thing to note is the people that actually downgraded, going from like 8 to 5 using RSA SHA-256 to RSA SHA-1. That's actually one agency. They had a whole bunch of domains. They just decided, I guess, say the heck with it and downgrade. The same with RSA SHA-1, NSEC 3 to RSA SHA-1 just with NSEC. I guess they just decided to say, who cares? We're not going to use NSEC 3 anymore. Interesting enough, obviously, this is kind of almost something to be expected. The majority of the DS hash algorithms used are both. They're just going to upload both. However, if they do make a choice and only upload one, they always seem to upload the RSA SHA-1 hash, mainly because it's probably shorter. It's easier to just copy and paste that in. At least that's my working theory. Technically, the use of SHA-1 in the federal government is kind of a gray area, especially for DS records, because they're not considered, the security of the record is not considered to be contained in that hash. It's just a checksum to check to see if you have the right key. The actual security could be said to be residing in that signature over that hash. So technically, you can use it, especially for NSEC 3 and DS records. Then we start delving into the NSEC 3 parameters, just to take a look. So we're looking at the iterations and salt values. And for the iterations, we're noticing that people really seem to like 10 for some strange reason. If you actually look into the RFC, all it says is that the value should be below 500. So that can be anything. So most people are going with something simple and just putting either 1, 10, a few going bold and going 100, but that's about it. And these are all of them, by the way. There's no ones that we didn't check. The length of the salt, we didn't actually look at the salt itself, just looked at the length. Again, there seems to be nice chunks that people are using. Obviously, bite-sized chunks, either 0, 8, 16. A few strange ones in there, but that's kind of like the length. But one thing we did notice was that the changes in the salt in iteration. For over a period of time, from June to August, so we're talking about a few months here, we looked at the 968 zones that were assigned using NSEC 3, and we kind of see how often they actually change that iteration value or the salt value. Of those, only 553 actually changed their salt value during that time, but 20 of them changed the durations value. But also we noticed that they actually did a key rollover, a KS or ZSK rollover during this period, and that's because for policy reasons we were encouraging people to do a ZSK rollover every 3 months. So at least all those zones did a key rollover during that time frame. So we noticed that the key rollovers, these parameter values are not synced with key rollovers, at least not all the cases. Some of them probably are, but not all of them. Because, I mean, say a lot of them didn't change either one. So basically, why are we doing this? I don't know. This isn't a question I want to really say right now. We need to hammer out right now at this 15-minute session. This is something to kind of think about within the community. Is this a problem? Is this a bad thing? Is this an okay thing, an acceptable thing? I mean, the whole idea of the NSEC 3 was to make offline attacks, or at least online attacks, or zone walking more difficult. And if you keeping the same iteration value and salt value the whole time, you're basically not utilizing it the way it could be utilized to actually prevent zone enumeration. Does there need to be changes in tools to kind of automatically change these values every time you re-sign, every time you roll a key, something like that? Or is it simply just an effort to just promoting best practices and saying, look, everybody, administrators, start doing this? Part of the reason why we're asking these questions is there's starting to be a undercurrent, a small minority, at least in the Gov community, that's looking at the deployment of DNSSEC and basically saying, well, it's stagnating, therefore, let's just get rid of it. It's kind of a strange kind of theory, but it almost seems pathologically anti-DNSSEC in times, especially when it comes in favor of their own particular favorite security protocol. They always see to say, like, it's better than DNSSEC, therefore stop doing DNSSEC. And they're using kind of this whole, we're bad maintainers of DNSSEC as kind of an excuse to say, let's just get rid of it and kill it. So we're kind of looking at that as saying, like, how bad is it actually? Is it something to actually worry about? Or is it something that they can just say, no, it's not really a problem. People are just exaggerating it. Okay, it's kind of quick, but we were kind of like running behind schedule. Any questions now, or something? Obviously, this is something a larger question. I'm willing to talk offline.
Hi, Melissa Muth, University of Pennsylvania. One thing you could do is continue with advocacy and giving talks about how you do it, because talking about something that's actually in production is meaningful to people. Yeah, I know. We've kind of been trying to do that. We're also trying to, NIST rides the special publications. SBs, and we're thinking about adding it to that and maybe adding more guidance to that. That's something I know we can do, is try and kind of encourage operator practice in the community.
Hi, Alex Dupuy at Google again. 2 questions. One, are you doing any kind of surveying or studying in terms of the number of validating clients used by the government, or the number of resolvers that are contacting you that are doing any kind of validation? And then the second one is a public agency whose actions, at least for a lot of agencies, are, matters of public record. I'm wondering why the interest in NSEC 3 is for hiding new product launches. It seems, especially since they're not actually getting any advantage from it, that using NSEC would probably be simpler operationally, and at least our resolver would stop sending you DOS attacks for a lot of queries, potentially.
Yeah. Okay, yeah, for your first question, we don't have that capability. Unfortunately, at NIST, we don't. There are places that data does reside, and we'd really like to talk to those people to kind of get that feeling, especially to see what kind of validation is going on. Oddly, that is in FISMA, the great Federal Information Security Management stuff, that all we're supposed to be doing validation. Every agency is supposed to be doing DNSSEC validation, and they're supposed to be reporting on it. But we haven't actually been able to get a hold of those numbers to see how well they're actually doing it. And for your second part, I don't know why they're using NSEC 3 either. I think mostly because they've just heard it's more secure, because it's 3. 3 is greater than 0. And some believe that they actually do have a threat of zone walking, and that a perceived threat, whether or not that's true, because most of the time it's just web servers and mail servers out there. So I'm not sure why.
There are certainly some cases, but they're the exception rather than the rule. And
yes.
Do you have any figures in terms of the breakdown on NSEC versus NSEC 3 in government domains at all? Didn't see it.
Where do I have it? I don't have. Oh, here's the total number. Oh, no. I did. Well. Oh, here's the number. 968 zones that were doing NSEC 3 that we were able to study, and the rest of them. It was about 1,000 or so. So the majority of them are actually using NSEC 3.
Okay.
Yeah.
Thank you.
Okay.
Brian Dixon. I was wondering if you have any data on, of the NSEC 3 instances, how many of them are opt-out versus opt-in, or don't have the opt-out configured?
I don't have those numbers, but we're collecting it for a time, and most of them are not opt-out. So they're all of it, except for Gov. But I think I don't know if Gov is or not. But yes, most of them are non-opt-outs. They're not signaling it. They're saying so they're not.
Cool, thanks.
Yeah.
So on the elliptic, do you have? This is Vijay from CERT. On the elliptic adoption, what are you doing to make it possible? Elliptic.
We're going to try and just get the word out, encouraging, but also we're trying to help get tool developments to make that an automated way, because algorithm rollover is really hard. so getting an automated tool out there that'll do it, and some actually will now, and try and encourage people to start doing it.
Thank you very much.
Right.
All right, thanks to Scott. And our next person is Moritz Müller, who's giving a presentation quantifying the quality of DNSSEC validation in the wild.
Yeah, good morning, everyone. My name is Moritz. I'm an OARC first-timer. I work for SIDN, which is the registry of .NL. And I want to talk about the root Canary project. And this project has the goal to measure the whole process of the KSK rollover and to be like an early warning system if things go wrong. We haven't seen the missing key coming, but yeah, we hope that we also can have a track of the future change then. These are the project partners. Some Dutch parties are involved. The ICANN is also passively involved there as well. And as I said, the root Canary project basically has the goal to track the operational impact of the root KSK rollover. And it has, the idea comes from the Canary and the coal mine to have like an early warning system if things go wrong. And we also measure the validation during the KSK rollover from a global perspective. So we want to have as many vantage points as possible to track the rollover. Basically, we have two different perspectives from our measurements. We have an online perspective and an offline perspective. The online perspective persists mostly out of RIPE Atlas measurements. We have RIPE Atlas as a default measurement implemented, so they probe our, all the 9,000, 10,000 RIPE Atlas probes carry out the measurements. We have the Illuminati HTTP proxy network. I will talk about a bit later about that. And we also want to do the APNIC DNSSEC measurements later on for verification as well. We also rely on offline perspective, so mainly on the traffic of the root name service, which already was provided on the OARC data platform, so we already had a look at that. Some words about our methodology. So we have basically signed, validly signed and bogusly signed records for most of the DS algorithms and for all the other algorithms. And But that gives us the possibility to estimate whether resolvers validate correctly, whether they fail to validate, or whether they do not validate at all. And of course, there are some corner cases that might be not be covered here as well. These measurements also give us some side effects, so we can, for example, measure algorithm support. But I wanted to talk about some of these by measurements later on as well. I mentioned that we have the active measurements. We use RIPE Atlas. Just a quick question. Does anyone not know what RIPE Atlas is? All right. I skipped that one then. But I might want to introduce Luminati network. Luminati is a HTTP proxy service. Which is free for users as far as I know. And these users, if they use the service for free, also act as exit nodes for these proxy services. And what we can do as a paying user, we can send HTTP requests through these clients to certain addresses. And these addresses then trigger DNS requests as well to the test domains. And thereby we can verify whether these exit nodes are actually behind validating resolvers or not. The Luminati network covers roughly 15,000 ASs, and which is interesting is that 14,000 of the ASs are not part of the RIPE Atlas ASs, so we have a measurement that adds to our RIPE Atlas measurements as well. For the RIPE Atlas measurements, we have RIPE set our measurements by default, so every hour, every RIPE Atlas probe now queries our test domains. So we have every hour a query to the validly signed domains and the bogus domains of all algorithms. So, but first have a look at the event of the 19th of September. So there we all know that the ZSK was added to the root zone. So the size of the DNS key response was increased to 14 bytes, as far as I know. Yeah, that should be it. And some people expected, or it could have been expected, that this might cause an issue with IPv6 fragmentation. So you might have seen some resolvers that fail. But in fact, we didn't see any of that. So this is a graph that shows the results of the RIPE measurements, and we see here the number of surf-fail responses for the validly signed domains over time. I just looked at a couple of hours before the new ZSK was in the zone, and a couple of hours after the ZSK was in the zone. The green line, the green vertical line, basically indicates when the new ZSK was in the zone, and we don't see a growth in change there at all, which is a good sign, I guess. Note, of course, that not all the resolvers query for the new DNS key right on the day when the new ZSK is in the zone, but it takes a bit because of the TTL of 48 hours. But if things would have gone wrong there, then you would have expected some increase in failures there. I also had a very brief look at root data. That was kindly requested, among others, by BRoot. I didn't have that much time, so I just briefly looked at the Miami side of BRoot. And there I looked at two things, basically. I looked at the number of TCP and UDP responses, and I looked at the DNS replies that had the TC flag set. And you would have expected, okay, if the size is getting too big, then resolvers would switch to TCP just to handle with too large responses. But again, here we don't really see an increase in TCP connections. This is the yellow line on the bottom, so it basically stays stable after the new ZSK was in the zone. The blue line indicates the ratio between UDP and TCP connections, and it also stays basically stable. The same goes for replies with a TC flag set. Also, they stay pretty stable. And my conclusion so far is, we can look, of course, a bit deeper into that later on, but that the increased size was not a big issue. And I think most people here in the room kind of predicted that as well, and that's a good thing, I guess. Now we're running quite a couple of measurements, and these measurements also allow us to get some other insights into the whole DNSSEC environment as well. And I want to discuss them a bit now. So we had a couple of questions. Okay, how well do validating resolvers support certain DNSSEC algorithms, especially new ones or maybe also some older ones? Can we use these characteristics to actually fingerprint some of the resolvers or some resolver software? And what happens